Hi, my name is Thomas, and today I would like to talk about mobile app security. Okay, a few words about me. I've been in the business of software development for quite a long time, and recently, so over the last 4 or 5 years, as part of my previous job at Apple, I started looking into information security. Today, I would like to talk about mobile app security, and this is the agenda. First, I try to motivate this topic. Why do we need security? Why it's important, and who is protected by this security? Then the bulk of the talk will be about mobile app communication, so the app talking to the backend. I will also talk about app deployment, so what is actually delivered to the user and how this could pose a security threat. And if time permits, at the end, I would like to ask all of you a favor by talking a little bit about how vulnerabilities are reported. So let's jump right in with an example. Okay, so here's an app. That doesn't. There you go. Okay. So here's an app from the store, from the App Store. And I just downloaded this. It's a regular app. I started for the first time. I look at the user interface, and I see that there is some button down here with an exclamation point. So I press it, and it shows some additional user interface. So just a regular game, a regular phone. Now, a different scenario could be I download the app, and it's the same app. It's the same phone. Okay, I launch it again for the very first time. Again, I see the button down here with exclamation point. I think it's important. So I tap it again, but a different UI comes up, this time asking me for credentials. So that's the scenario we want to prevent. Someone else has changed the UI of our app. This went through the network and someone manipulated the data. And today I would like to talk about how this is done and how to prevent it. So why do we need app security? First and foremost, we want to protect the user. We want to protect the user's data. There's critical information that's sometimes sent over the network, like user credentials, personal information, session tokens, and maybe less obvious, it's also tracking information. I'm not in the business of saying tracking is bad. I'm just saying that whenever an app tracks activity, make sure that this information is secured and is only seen by the people that should see it. But besides eavesdropping, we also want to protect the user from tampering the data. That's the example I've shown before. We also need security to protect you, the developer, the company. In the animation I've shown before, there was a change of user interface. There could also be a change of behavior, like an app crashing by sending a handcrafted data packet to the app. And we want to prevent this. This is bad for you as a company if your app is crashing all the time or if your data leaks. In general, vulnerabilities have a big impact on your business. And that's why it should be in your interest to avoid them and to learn about them and to fix them. I want to stress that app security is not a good tool to protect your backend. Some people use encryption and encrypted communication to prevent that other people see the protocol that is used between the app and the backend. And mobile app security is not the right tool for this. As an example for this, this is a screenshot from like 3 or 4 years ago when I first looked into information security. I used LinkedIn a lot, and there was this nifty functionality that I could see how popular I am against my colleagues at Apple. So I reverse engineered the protocol between the app and the backend and just wrote my own bot simulating some social activity. I stopped right before being number one because was definitely deserves to be number one. I would like also to spend a couple of minutes on explaining what a hacker can do. I think the talk right after this one will show this in more detail. But in general, a hacker can listen to everything that's sent over a Wi-Fi as long as the Wi-Fi is kind of open or the password is known or the Wi-Fi has weak security. And that's way more often the case than you might think. It's in hotels, airports, coffee shops, on conferences like this. All the data can be seen. Now, the data can be encrypted, that's what it should be, but still someone can capture the data, even though it's encrypted, cannot really understand what's going on. But an attacker can just listen in, store everything, and then analyze the data. And if you're part of the network, you might also be able to change the traffic by imitating the network gateway. There are certain attacks for this. Or you can buy some fancy hardware off the shelf to extend an existing network, like a hackable access point. One example is a Wi-Fi pineapple. Or you can just own the network. That's the easiest. And that's also more often the case than you might think. So at your friend's house, at your work, someone owns this network and they might have an interest in reading your data. With physical access, an attacker can do even more. So here, I just show quickly what it takes. The animation's still not working, I'm sorry. Let's see. Okay, second time is a charm. So it just takes a few seconds to route all network traffic through a proxy. And that's a setting that 98% of the people will never see, and they won't look for. I think in this room it will be different. Many people know this feature. But it's built into the OS, and now all traffic from this phone will go through that IP and can be eavesdropped and maybe changed. So with physical access, you can redirect traffic. You can also register the phone on some malicious access point. And one thing I'm not really going into too much detail in this talk is you can install patched applications that look exactly like the application you know, but that are patched in a way that data is sent to a different server. And you will never see the difference other than there are no updates for this app. And this can be done on devices that are not jailbroken. So if you, at the end of the talk, if you leave the cinema or stay for the next talk, that's the image you should keep in mind. So when I started working on this talk, beginning of September, I wanted to have practical real-world examples. So I downloaded the top 200 free iOS apps. And these are all the icons, obfuscated a little bit, and not in order. But during the talk or throughout the talk, I want to highlight the apps with vulnerabilities. So let's get going. The communication between the app and the backend. So I'm telling the most obvious thing here. Clear text communication is bad. You should not do this. Again, as an example, probably the animation doesn't, oh, it works. So here's an obfuscated app. It has a sign-in dialog. I'll type my credentials in. At the same time, someone on the network starts a proxy, acts as a gateway. Once I have my credentials typed in and hit sign in, the data is captured. I can look into the packet and I see my username and my password. That's clear text communication. That's when you communicate with HTTP. So don't do it. Does not provide any security. And obviously there are things you can do. You can sign the content to prevent tampering, or you can encrypt yourself, but it's kind of false safety because the encryption key is probably embedded in your app and can be extracted anyway. So don't reinvent the wheel. There are better solutions already available. Now, some of you, the iOS developers that already created an iOS app, they know about something called app transport security. And that's something that was introduced 4 years ago. And it actually prevents by default that HTTP connections can be used. So there should be no app that uses HTTP because HTTP is blocked. But sometimes that's kind of like in the way during development. So there are ways to whitelist domains for legitimate reasons, like you implement a browser, obviously HTTP should work. Or because you want to work with the staging environment during development, and that's only available through HTTP. So you can disable specific domains, or you can just disable the whole thing. But don't do this in production. Okay, I guess everyone can anticipate what's coming. We have the 200 apps I downloaded. And let's have a look who is actually communicating using HTTP. Is there a guess in the room? Like, what do you think? 10 apps? 20 apps? Anyone has an idea? What do you say? 20? So it's 55 apps using HTTP to send sensitive information. So I looked at the data that is sent, took quite some time, and it's user credentials, it's session tokens, it's sensitive information like where you are at the time that is leaking because people use HTTP. And it's actually 25 more apps that send big chunks of data that I wasn't really able to understand because it's like protobufs or just binary data, or it was compressed. And I only had 10 minutes per app. So we are at 80 apps. 80 apps from the top 200, so 40% use clear text communication. And I'm not counting, just to stress this point, I'm not counting assets. So if you download your image from some HTTP CDN, I'm not counting that. But 80 apps send exploitable or likely exploitable information. And the numbers behind the app count are estimated download numbers. So in total, 117 million downloads for 1 month. That's an estimated download number for a month. 170 million downloads with clear text communication. And I said there's already a better way, HTTPS. I'm not saying anything new. HTTPS is using something called transport layer security, which has 3 properties. It provides privacy, so that's encryption. It provides integrity, so you can be sure that no data is lost and no data was replayed by an attacker or something like this. And there is something called trust, and that the idea is that you can be sure that you're really talking to the server you want to talk to. Let's talk a little bit more about this. Trust is done using digital certificates. There is something called a certificate authority. There are hundreds of those, and you can get a certificate from this certificate authority. A few years ago, this was expensive and cumbersome, but nowadays it's quite an easy process. There's a project called Let's Encrypt that provides free certificates, and that has improved the situation a lot. So there actually is no good reason anymore to not use TLS. But the definition of trust that is used is that the user trusts a certificate. And there is an easy way to just install a certificate and explicitly trust it. Just takes 10 seconds again, you hit install a couple of times, and then this specific certificate is trusted. And this is device-wide. So if you do this on one device, then all apps automatically trust this certificate. And that's great. That's great for development, for instance, because you can really do what you actually want to prevent. You can look into the data and you can see what the protocol is doing and what the data inside these encrypted messages is. It's great for debugging. But to stress it again, that's one of the reasons why TLS as well is not a good tool to protect your backend, because you can still see what's going on. If I install a certificate on one device, I can see the traffic for all apps on that device. And there is a little bit of a pattern here, because before there was a way to disable this. And here again, there is a way to disable this. You can disable the trust completely for an app, but never do this on production. This is just a debugging tool. It's a tool when you have like a ton of devices, testing devices. You want to put your code on those devices and not install a certificate every time. Don't do this on production. Well, so here are the 200 apps. And here are the 80 apps that already have a problem with clear text communication. And let's just add a few more, 17, to those that don't validate the server certificate, that just trust everything. And key here is that if you trust everything, then people can sit in the middle and do so-called man-in-the-middle attack. They can act as the server. And they can send you whatever certificate as long as it looks like a certificate. And that's easy to do. You can send a self-signed certificate. So a total of 97 apps out of the top 200 have improper security with their communication. Now, the solution to all of this seems certificate pinning. I already mentioned there are good reasons to not fully trust the so-called trust chain of the transport, the TLS. So it just takes a second to install a trusted certificate. Companies have been caught by just installing some certificates on work phones. And if we want to go a little bit more crazy, there were incidents of compromised certificate authorities. Certificate authorities were hacked, and certificates for pages like google.com were generated. And in some cases, even the government is putting pressure on CAs or owns certificate authorities and can just create whatever certificate they want. The good thing is, well, we own the app, and most of the time we own the backend. So we know the certificate of the backend. And we can leverage this knowledge by doing something called certificate pinning. So a lot of code. This is the important line. We compute some kind of fingerprint from the certificate and see if it's the one we expect. Easy enough. And I highly recommend doing this. But there are some considerations when it comes to certificate pinning. So you have to think through all the edge cases. For instance, certificates can expire. If you have a hard-coded hash somewhere in your app, you have to deal with this. If this is a planned event, you know in a few months the certificate expires, then you just release a new version of your app. But sometimes it's not a planned event. Maybe your certificate is compromised. A typical approach then is to not pin against the so-called leaf certificate, so the certificate of your server, but check for the certificate of the certificate authority you're using. But this trickles down, obviously. What if you want to change the certificate authority? A lot of people switch to Let's Encrypt when they offered free certificates. So you have to think through all of this. It's a little bit more maintenance. Still, I highly recommend it. So that's it for communication. I'm not showing flaws in certificates or certificate pinning, because this is really what you should do. And when you do this, you're like top 1% of the apps when it comes to security. So now I want to talk about app deployment. What do I mean with this? So again, I state the obvious. Your code ends up on the user's device. Sure, when you download it from the store, it's encrypted, it's signed, and it's stored as such on the device. But at some point, the code has to be decrypted, otherwise it could not be executed. And when you have a jailbroken phone, you can just attach the debugger to this process and dump the memory, and it's decrypted. And you only need one jailbroken phone, right? Once you have this information, you can use whatever you extract from this app with like writing your own tools. And there is interesting information in the app. Mainly it's strings, so every kind of text, and that text can contain passwords, tokens, symbols, private keys, a lot of stuff. And it's really easy actually to extract information. So this is a fun example. So from all the apps I downloaded, there are handy tools to decrypt them all in a batch. I look for code. So here I'll look for, in the folder with all the top 200, I look for code and write all the file names in some temporary file, take that file again, and then look for strings in each of these code files and look for love. And there are a couple of hits, but I like this one because Google obviously still is in love with Marissa Mayer. And this is a string that people want you to find. So someone put this in there as an Easter egg. But there is a lot of other information that people are not aware that it can easily be extracted. And especially when you use third-party cloud services, this becomes a problem because they usually work with keys and secrets. And if you call these services directly from your app, these keys and secrets have to be stored somewhere, and they are stored in your app. And then someone can extract them. And it sounds like a good idea because you don't have to worry about the backend. You don't have to worry about commissioning servers and having engineering resources. And so here are some real-world examples. Some app is directly uploading the profile picture to an object storage, or account management is done using a cloud service. Or one app even sent out directly from the app the verification for the registration via a text message third-party service. The key thing here is if the app can do it, an attacker can do it. So I don't need the app. I can just upload whatever I want on that object storage. And there is no check. Sure, should be a picture, but who prevents me to upload some web page? And in this specific case, it was exposed directly under the domains, under the company's domain. So I can basically just change the website of the company. Or I can read out information from other users using the account service. Or I can just spam my friends with text messages in the name of the company of the app, the vendor of the app. So there are obviously countermeasures, and I recommend implementing those. The straightforward solution is just have one backend, and that's yours. And if you use third-party services, then let your backend deal with this. So the communication between the app and the backend is really just one communication to your backend. Obviously, that has to be secured as well. But if you have a backend, you have much more control. You can restrict certain things, like is a profile picture really an image? Or you can throttle the access even dynamically. If the user gains some trust over time, you can allow them to upload bigger files. And if you have to use third-party services directly from your app, then restrict generously. So I know it sounds like no one would do this, but in the top 200, there are examples of apps using the same AWS key for the Amazon S3 object storage that can then be used to spin off some EC2 instances with full root access. And if you want to do it right, then you should use temporary security credentials so that you ask your backend for temporary security credentials, and in the background, the backend asks the third-party service, and then you can use those credentials from within the app to perform your actions. Oh, here we have the picture again. 200 apps. We already had 97 apps with communication flaws. And let's add 14 more with embedded secrets and keys that can be exploited. So we are at a total of 111 apps in the top 200 free apps on iOS that have significant security flaws. I don't know how you feel about this, but I think it's crazy. So last topic is just another recommendation, symbol obfuscation. So we already talked about the code being more or less public or can be extracted in a decrypted form. And the code is really interesting. And a lot of people look at the code, but a binary is really big. So where do you start? The typical starting point for someone interested in this kind of stuff is using method names. So you look for something sticking out. So here, that's Snapchat. And if you look in all the method names for secret, you'll find interesting stuff. I mean, the list goes on. It's just a screenshot. But you already see, oh, there are some secret features that can be somehow enabled. So you can check the code and see how it's done. I mean, as someone who worked for Apple for 8 years, I can tell you that leaking this kind of information can happen fast. So the solution is, don't use these kind of names, use random names. Just replace these sensitive names with random strings. And obviously, you won't do this during development. But when you ship it, when you upload it to the store, there are tools that automatically can obfuscate strings. And this will take this kind of low-hanging fruit for an attacker to understand your code. It will be way more complex to find interesting things. And there is kind of like this idea that every 10 more minutes it takes to find something interesting, half the people will give up. So it's really a game of let's slow down whoever is looking at your stuff. As I said, there are a ton of tools. Actually, I don't recommend using tools because there is a risk of over-obfuscation. And then you can have name clashes, and you can have, especially on iOS, there are things like key value coding and nib files, and all reference these method names, and there can be problems. But it's really easy to do. Like, just have a header file where you redefine the name of the sensitive method name to something random. So, highly recommended. Don't do it on everything, but on a few things. Obviously, you should make it look like something else. Otherwise, people know, oh, okay, so there is an obfuscated string. That seems interesting. So that's it for the main part of the talk. Now, I want to talk about reporting vulnerabilities. So when I started off with this talk and looked at the 200 apps, I feel it's a social responsibility to tell the vendor that there is a problem. So I reached out to a lot of companies. But it's not that easy. People or companies, they don't, unfortunately, have like a website that says, well, if you find a vulnerability, just like write an email to this address. And that's what I'm asking you to do. Because I will eventually publicly disclose all these problems, because there's also a social responsibility to the user, that they have to know there is a problem and that their data is not secure. But I want to do this with the vendor. I want to give the vendor enough time to fix the problem, and then a grace period for a lot of people to update, and then can be disclosed. So you have to ask yourself, do you want to know if someone finds a vulnerability in your code? I guess so. You want to fix it, right? And then the next question is, how easy is it actually to reach you, to contact you when I find something in your app? Most of the websites don't even have an email address anymore listed somewhere. Or it's not working and the email is bouncing. And you have to reach out on Twitter or on Facebook, which I think is really not the right thing to do. So there's something called responsible disclosure, something I try to follow. And the idea is that all collaboration is done in good faith, so we want the same things. I want that the vulnerability is fixed. I want that the credentials in the very first example that I type in are not leaked and not everyone can look at them. And 3 points I picked out of responsible disclosure, which is like a real process, people can look it up, is make it easy to find, communicate often. It's the worst thing when you reach out, the company says, yeah, there's a bug, we'll fix it, and then you'll never hear again if the fix was deployed or not, because they don't write it in the changes. And be transparent about a disclosure. A lot of people are afraid. They say, as I said before, security problems can have an impact on your business. But it's even worse when you're not transparent about it, when you're not honest. So when someone reaches out to you with a vulnerability, fix it, and then let your users know. So in summary, 200 apps, 111 can be exploited. And I'm sure that you want to be in these top 200 apps. Everyone wants to be there. And if you are, people will look at your code and they will look at your communication. So to not be a highlighted icon here, that's a checklist. Make sure everything is secured using TLS. Validate the certificate from the server. Use certificate pinning. Check your binary for keys and secrets. Just like put the hacker hat on and attack yourself. Obfuscate signatures if possible, and have a good vulnerability disclosure process in place, because something will happen if you're in the top 200. So that's it. Any questions? Thank you. I don't see anything. Okay. So I haven't reported them all yet. It's a lot of communication, and it's slow communication. But I would say half the people acknowledged, or half the company acknowledged that there is a problem and are working on a fix. Only one app, so I started 4 weeks ago, only one app so far has actually fixed something. And the other half, I never heard back. And I tried multiple times through different channels. So that's why this plea of like, please don't be like this. Any other questions? Yeah? So the way I understood this question is I showed certificate pinning and there was a hash. And can I just in the app, in the decrypted app, change that hash to mine? Yeah, I can, absolutely. And that's, again, let me reiterate again, that's why even certificate pinning is not the right tool to protect your backend API. You can, I mean, that's even a more complicated way of doing it. The easiest way is just to disable in code the certificate check. Yeah? Sure. Is there a bug? Crap. There you go. Yeah. It's a weak hash, absolutely. Quite honestly, I only use the one instead of like SHA-256 because otherwise it wouldn't fit, or at the time it wouldn't fit in style-wise on the slides. Obviously, I shouldn't do that. But you're right. You can use other hashes, and you should. Correct. Yeah. So the question was, what about Android? So obviously my background is iOS, and there are some iOS-specific details in this talk, but most of the stuff, especially that clear text communication is bad, that you can disable the trust on TLS, certificate pinning, all these kind of things are totally applicable to Android. But things like the app transport security piece I mentioned, I'm not aware that that's actually available on Android. Yeah? I can repeat the question.
I was wondering if any of the companies you contacted have any bug bounty programs.
Well, no, they don't. It's I'm not getting rich doing this, but it's actually a really good thing to think about. So if you feel that people should really, more people should spend time looking at your code and finding vulnerabilities and letting you know, then a bug bounty program is a really good approach. Anyone in the top 200 here? Okay. The About You app was actually really good, I have to say, yeah. Anything else? You can, let me put the contacts there again. Just reach out if you have questions, you want to discuss, you need help maybe. Just let me know. Cool, thank you.